Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Subramaniam with a PhD in Chemistry. In today's session, we are continuing with a quick revision of Unit 4 Chemical Kinetics Class 12 Part 4, the last part of this unit. So before starting with the unit, I'd like to share with you some tips to score more marks for Chemistry NEET. So the important and scoring chapters in chemistry are biomolecules, polymers, chemistry in everyday life, environmental chemistry, periodic table, chemical bonding, and examples from surface chemistry. The questions from these chapters are asked every year in NEET. The next thing is that improve your speed in physical chemistry by consistently solving problems. Prepare a list of formulas and reactions from the start and have a glance at them often so that you can remember them whenever you are solving problems or giving tests. Taking the case of organic chemistry, you have to understand the concepts and reaction mechanisms well. GOC or general organic chemistry like alkanes, aldehydes, aromatic substitutions are all very important. And in inorganic chemistry, it requires lots of reading from NCERT and revisions, and you have to make proper notes all along the way. Don't give maximum time to the part which you like more and less time to the one which you find difficult. Give sufficient time to each portion, whether it is organic, inorganic or physical, so that you can cover the full syllabus in time. If you find anything difficult to study, then ask your teachers or you just refer to the portions I am uploading and you can clear all your doubts. Then just try to solve the previous year NEET papers of chemistry chapter wise multiple times if possible. You practice all the MCQs which I have given. I will be uploading around 500 MCQs from each unit once I finish off all the portion. And then don't immediately see the answer of a MCQ if you are not able to solve it. Read again the topic from where the question is asked and then attempt the question again. So now we will move on to the concepts of important topics today. First, last unit, if you remember, we were talking about the energy diagram for an exothermic reaction like A, B added up with C. First A is not leaving B, at the same time C is getting attached to B, and then after that in the third step A gets removed from this part and B and C joins together. So now we will take a graph with the reaction coordinate on the x-axis and potential energy along the y-axis. This is the product. What happens is that you can see here, the starting of the reaction, reactant A minus B, AB, not B, A minus B, it is AB plus C, it is the reactant, and it reaches the activation energy. The activated complex is formed here, which is the transition state ABC. Now finally we reach the product, and you can see A plus BC, that is the product, and now this is the difference in energy, delta E. And this is the reaction energy diagram for an exothermic reaction, and you can see the reactant here and the product over here, and this is the potential energy and the reaction coordinate is given here. So I think this is very simple for you now. Now next, what is chemical kinetics and catalysis? You can see that catalyst it's a substance which changes the rate of the reaction, that is it can either speed up a chemical reaction or slow down a chemical reaction, and it itself doesn't change chemically. Till the end of the reaction, the catalyst remains unchanged, and this process is known as catalysis. So the example is given here. Now next, you can see here the catalyst, we can classify them into two. One is positive catalyst and another is negative catalyst. Even catalysis can be divided into two: homogeneous catalysis and heterogeneous catalysis, enzyme catalysis. Okay, now what is meant by homogeneous catalysis? Here the catalyst will be in the same phase as the reactants and it is eventually evenly distributed throughout. And catalysis in gas phase, you can see here 2SO2 plus O2 plus NO gives 2SO3 plus NO. Here again 2CO plus O2 plus NO gives 2CO2 plus NO. CH3CO CHO plus I2 gives CH4 plus CO plus I2. So always in any reaction the catalyst does not undergo any change. It remains unchanged till the end. Now catalysis in solution phase. C12H22O11 plus water plus H2SO4 gives C6H12O6, C6H12O6 plus H2O. And now other reactions also you can see, and that is the catalysis in a solution phase. So these are some examples for that. You can just go through these examples. Now next is heterogeneous catalysis. Here the catalyst will be in different phase. In homogeneous it was in the same phase, but this is in a different phase from the reactants. It is also known as contact catalysis. So here with gaseous reactants you can see a few examples are given here. SO2, O2, platinum is given, same platinum is over here, and the product side you can also see other N2 plus 3H2 plus iron which is added as a catalyst. Here also iron doesn't undergo any change. Then with the liquid reactants also it's given here, and solid reactants. So here what happens is that the most important features we have to go through some more features of this which is given here as characteristic of catalytic reactions. And as I already said, they remain unchanged in mass and composition. Only a small quantity is needed. Then it is very effective only when it is finely divided. Then it's very specific here, C2H5OH. In presence of Al2O3 we get CH2 plus H2O. Then in presence of copper, here C2H5OH gives CH3CHO plus H2. So in general it cannot initiate or start a reaction. Like H2 plus O2, there is no reaction, it cannot initialize. And H2 plus O2 here gives 2H2O. But mostly catalyst, when it is added to a reaction, as I have already said, it just lowers the activation energy barrier and thus helps in speeding up of reaction. And normally a catalyst does not affect the equilibrium position, and also it depends on temperature. So these are the few characteristic of catalytic reactions. Now catalytic promoter, what is a catalytic promoter? That is any substance which itself it's not a catalyst, but it promotes the activity of a catalyst. Though the substance itself is not a catalyst, it promotes the activity of a catalyst. Here you can see N2 plus 3H2 gives 2NH3. Here the promoter is MO or Al2O3. Here CO plus 2H2 ZNO plus CRO gives CH3OH. And here catalytic promoter, it is not a catalyst but promotes the activity of a catalyst, and it changes the lattice spacing and increases the peaks and cracks. Now what is catalytic poison? It is a substance which destroys the activity of a catalyst to accelerate a reaction. For example, N2 plus 3H2 gives 2NH3, poison is H2S, SO2 plus O2, 2SO3, and in presence of platinum, here the poison is AS2O3. So here preferential adsorption occurs and chemical reaction takes place. Now next is autocatalyst. Here autocatalyst means one of the product itself acts as the catalyst for the same reaction. Here you can see the reaction is given on the product side, CH3COOH itself acts as a catalyst. And two more examples are given here. Similarly, negative catalyst or inhibitor, that is a substance which reduces the reaction rate. And you can see for this particular reaction, inhibitor is 2% ethanol, here 2% here glycerol is the inhibitor, and for fuel combustion PbC2H5O 4 times is the inhibitor. See, remember they will be giving you the reaction and they might ask what can be used as an inhibitor. From the choice you should know to distinguish the correct inhibitor. Now next, what are the theories of catalysis? So intermediate compound formation theory, and it's very simple. A plus B gives AB, and A plus C gives AC, and AC plus AB, AC plus B gives AB plus C. Just interchanging and writing in. For example, 2SO2 plus O2 gives 2SO3. Here in this reaction 2NO plus O2 gives 2NO2, that is the intermediate, and NO2 plus SO2 gives SO3 plus NO. And next is C6H6 plus CH3Cl gives C6H5CH3 plus HCl. And here the intermediate is CH3Cl plus AlCl3 CH3AlCl4. Then that intermediate, see here, and this reacts with C6H6 and then finally you get this product. So I hope you understood. You just follow this principle. A plus B gives AB. So here A plus B gives AB, and then A plus C gives AC, and A plus C gives AC, then AC plus B, AC here plus B will give you AB plus C. So you have to follow this and accordingly you can follow this example also. Here you take A plus B here and A plus C. So from here you can understand NO2 here, that is a product here, and plus SO2 from here. Leaving out oxygen, you have to take the two other substances on the reactant side. And that is you get finally here again NO plus O2 gives NO2 intermediate. This NO2 reacts with SO2 over here to give you the product SO3 plus NO. Similarly, in this reaction, what is the intermediate form? This is the intermediate form. So you can see this intermediate over here in the next step. Intermediate plus this. Okay. So CH3Cl, this won't come here in the reaction. This comes here and the intermediate. Okay. So now I hope you understood what is the intermediate compound formation theory. And next is here also see this intermediate comes here and SO2 comes here. So oxygen same, it is not taking part or coming over here in the reactant side. Now next we have to look at the theories of the catalysis. First is adsorption theory. It's very simple. Then you can see here CH2 plus hydrogen in presence of nickel gives CH3. And you can see over here a hydrogen is getting adsorbed. Already we talked about adsorption in surface chemistry. You can go through that particular unit to understand the concepts of adsorption. So here the adsorption of hydrogen molecules happens, then breaking of HH, hydrogen bond, and next step is formation of activated complex, and finally decomposition of activated complex and desorption of ethane molecules. So here we learnt everything, all these terms in the surface chemistry. Those who have any doubts, please go to the unit surface chemistry and go through these definitions. Okay, now next is adsorption theory and catalytic activity. In metals in a state of fine subdivision or colloidal form, they are rich in valence bonds. So they are more efficient catalysts than metals in lumps. So finely divided catalysts are more effective than lumps in metal in lumps. And catalytic poison normally occurs because the poison blocks the free valence bond on its surface by preferential adsorption or by chemical combination. And promoter, whereas it increases the valence bond on surface of catalyst and it changes the crystal lattice and increases the active centers. Okay. Now acid-base catalysis. So homogeneous catalytic reaction catalyzed by acids or bases, or both acids and bases, these are known as acid-base catalysts. For example, inversion of cane sugar, when it reacts with water, you get C6H12O6 2 times. Hydrolysis of ester, H2O, that is in presence of acid and base, you get an acid and an alcohol. Then decomposition of nitramide, in presence of base, you get N2O plus H2O. And all these are examples for acid-base catalysis. Now, what is meant by enzyme catalysis? It is a catalysis brought by enzymes. So we have learned this in another unit. These are catalysts in biological systems. We learned it in biomolecules also. Substrate fills into the active site, and much like a key fits into the lock. We can see E plus S, ES gives P plus product plus enzyme. Okay, this is enzyme plus substrate. You get enzyme substrate complex, and finally we get product and enzyme. Okay, now what are the characteristics of enzyme catalysis? Most efficient catalyst known, then it's marked by the specificity, maximum at the optimum temperature, and optimum pH also it is maximum. It is greatly affected by inhibitors and greatly enhanced by activator or coenzyme. And examples are inversion of cane sugar by invertase, which is an enzyme present in yeast. And you can see this equation is very important. You can get this equation also, and the product will be given in the choices. Then conversion of glucose into ethanol by cymase, which is present in yeast, that is glucose is converted into ethanol. Now hydrolysis of urea. What is urea? NH2CONH2 H plus gives 2NH3 plus CO2. Okay, now with that we come to the conclusion of this unit. I will be uploading MCQs, and remember for this particular unit's MCQ we have got so many problems to solve, and I will be explaining those problems as MCQs, as well as I will be uploading simple tricks to solve the problems from this unit, and also some other tricks from. Also after this lesson immediately I will be uploading the another unit, redox reaction, and the MCQs based on it. That's a very important lesson, and as usual, as I say, do please like, subscribe and share my channel with your friends, and don't forget to press the bell icon, so as soon as I post a video, immediately you will get notification for that. With that, I am coming to a conclusion of today's session, and please wait for the upload of MCQs at the earliest. I will be doing it soon, because as you all know, the next NEET is 2022 is probably likely to be held in July 2022. So before that, I would like to conclude all the units, finish it off, and make you practice most important MCQs. I am sure you'll all be finding this very helpful. With that, I am coming to a conclusion of today's session. Thanks for watching my video.